Welcome to AI Frontiers, your premier podcast for cutting-edge developments in artificial intelligence research. In today's episode, we explore decoding language intelligence. Insights from Computational Linguistics research from May 2025. This podcast examines how recent advances in computational linguistics and natural language processing are reshaping our understanding of machine intelligence. Throughout this episode, we'll identify key research themes, analyze groundbreaking methodologies, and explore the implications for future language technologies. Join us as we dive into the fascinating world where machines learn to understand and generate human language with increasing sophistication. In today's exploration of computational linguistics research, we'll embark on a journey through cutting-edge developments that are transforming how machines process language. We'll examine the intricate mechanisms behind how artificial intelligence systems understand and generate human language, from the fundamental architecture of language models to their practical applications. Our analysis will identify key research themes currently shaping this rapidly evolving field, including enhanced reasoning capabilities, multilingual challenges, and ethical considerations. We'll also analyze the groundbreaking methodologies driving innovation, such as chain-of-thought reasoning and multi-agent collaborative frameworks. Finally, we'll explore the profound implications these advances hold for future language technologies, from more culturally aware AI systems to more efficient and trustworthy language models. Computational linguistics represents the interdisciplinary field where computer science meets linguistics, focusing on developing computational methods and models to process, analyze, and generate human language. This field has gained tremendous significance in recent years, particularly with the rise of large language models capable of understanding and generating human-like text across multiple languages and modalities. The significance of computational linguistics extends far beyond academic research. It forms the backbone of numerous technologies we interact with daily, from virtual assistants and machine translation services to content recommendation systems and search engines. As artificial intelligence continues to advance, computational linguistics plays a crucial role in bridging the gap between human communication and machine understanding. What makes this field particularly exciting is its direct impact on technologies we use daily. The research we're discussing today represents the cutting edge of how computers process, understand, and generate human language, with implications that extend far beyond academic interest into practical applications that are reshaping our interaction with technology. Recent research has identified significant challenges in language model reasoning and tokenization. One major advancement involves models that can dynamically switch between short and long chain-of-thought reasoning modes based on task complexity. This approach reduces computational costs by 20 to 30% while maintaining high accuracy on complex tasks, representing a significant efficiency gain. However, researchers have also uncovered fundamental limitations in how language models process text at the character level, a phenomenon dubbed the strawberry problem. This refers to language models' consistent failure at seemingly simple character-level tasks such as counting letters in words. The issue stems from tokenization methods, particularly subword-based approaches like byte-pair encoding, which impede symbolic computation by merging or obscuring atomic reasoning units. Researchers have introduced the concept of token awareness to formalize how poor token granularity disrupts logical alignment and prevents models from generalizing symbolic procedures. Notably, Chu and colleagues demonstrated that token structure dramatically affects reasoning performance, causing failure even with chain-of-thought prompting. Their research revealed that even small models with appropriate tokenization can outperform larger systems in structured reasoning tasks, challenging the assumption that scaling alone will solve reasoning limitations. Research addressing multilingual and cultural challenges has become increasingly prominent in computational linguistics. Several researchers have introduced benchmarks for interpretive slang translation, encompassing tasks like slang detection, cross-lingual slang explanation, and contextual slang translation. These benchmarks help evaluate how effectively language models can navigate the nuances of informal language across different cultures. Other researchers have presented hierarchical routing approaches for neural machine translation, improving the quality of translations between linguistically distant languages. A particularly significant contribution comes from Chu and colleagues, who introduced the cross benchmark for assessing cultural safety in vision language models. This benchmark includes over 1,200 multilingual visually grounded queries spanning 16 countries and 14 languages, providing a comprehensive framework for evaluating how well AI systems respect diverse cultural norms. Multi-agent translation systems that mimic human translation workflows have shown promising results, outperforming traditional monolithic models in translation quality and adaptability. Contrary to common assumptions, research has also revealed that multilingual models often exhibit stronger gender bias than their English-only counterparts, highlighting the complex challenges in developing truly inclusive multilingual AI systems. Efficiency and ethical considerations have emerged as critical research priorities in computational linguistics. Recent studies have demonstrated remarkable cost optimization in tasks like text-to-SQL conversion, achieving similar benchmark scores at only a fraction of the computational cost of previous approaches. However, researchers have also identified what they term the hallucination tax of reinforcement fine-tuning, where such training reduces model refusal rates by approximately 80% but simultaneously increases the tendency to hallucinate answers to unanswerable questions. This trade-off between helpfulness and truthfulness represents a significant ethical challenge. Privacy concerns have also gained attention, with researchers examining the interwoven roles of large language models in authorship obfuscation, mimicking, and verification. Several papers have introduced frameworks specifically designed to detect caste-based biases in large language models, revealing that current models systematically reinforce biases, particularly against marginalized groups. Additionally, research on long context understanding has revealed that models struggle beyond 64,000 tokens when dealing with complex narratives like novels, challenging the assumption that simply extending context windows automatically leads to better long text understanding. These findings highlight the need to balance performance improvements with responsible AI development practices. Several breakthrough discoveries are reshaping computational linguistics research. Perhaps most fundamental is the finding that tokenization fundamentally bounds reasoning success in language models. This architectural limitation, overlooked until recently, reveals that symbolic reasoning ability is not purely a function of model size or training methodology but is deeply conditioned on token-level representations. Another significant discovery involves backward reasoning for complex task planning. Researchers have demonstrated that backward reasoning, which involves planning from the terminal state backward, significantly outperforms traditional forward approaches for complex tasks. This challenges conventional wisdom in AI planning, which typically relies on forward reasoning. Cultural safety gaps have been identified in all vision language models, with even the best systems achieving only 61.79% awareness of cultural norms. Research on what's called the internal chain of thought has revealed how language models implement sequential reasoning layer by layer despite their parallel architecture, providing unprecedented insights into their internal processing. Finally, multi-agent systems have been shown to outperform monolithic models in translation quality and adaptability, suggesting a shift toward more specialized, collaborative AI frameworks for complex language tasks. Several common methodologies are driving progress in computational linguistics research. Chain-of-thought reasoning has become a foundational approach, eliciting intermediate reasoning steps from language models before producing final answers. This technique mimics human problem-solving processes and has proven effective across various reasoning tasks. Retrieval-augmented generation represents another widely adopted methodology, combining language models with external knowledge retrieval to enhance factual accuracy and reduce hallucination. Multi-agent collaborative frameworks involve multiple specialized AI agents working together to accomplish complex tasks, such as multimodal essay scoring or translation quality assessment. These frameworks decompose complex tasks into more manageable components, allowing for specialization and more robust performance. Model compression techniques, particularly quantization, aim to reduce the computational and memory requirements of large language models without significantly degrading their performance. These approaches enable faster inference, lower energy consumption, and deployment on resource-constrained devices. Finally, LLM as judge evaluation methods, where large language models evaluate outputs from other models, provide scalable assessment alternatives to human evaluation. While this approach offers consistency and comprehensive assessment, it may inherit biases from the underlying models, highlighting the need for careful validation. The paper, Multimodal Cultural Safety, Evaluation Frameworks and Alignment Strategies by Chu and colleagues addresses a critical gap in the evaluation and improvement of vision language models across cultural contexts. The researchers introduced CROSS, which stands for Cultural Reasoning for Safety in Systems, a benchmark including over 1,200 multilingual queries spanning 16 countries, 3 everyday domains, and 14 languages. What makes this benchmark particularly innovative is its focus on scenarios where cultural norm violations emerge only when images are interpreted in their specific cultural context. To evaluate model responses, the researchers developed cross-eval, an intercultural theory-based framework that measures 4 key dimensions: cultural awareness, norm education, compliance with cultural norms, and helpfulness. Their evaluation of 21 vision language models revealed significant cultural safety gaps across the board. Even the best-performing model achieved only 61.79% in cultural awareness and 37.73% in compliance with cultural norms. The researchers developed 2 enhancement strategies: supervised fine-tuning with culturally grounded data and preference tuning with contrastive response pairs. These strategies substantially improved cultural awareness and compliance while preserving general multimodal capabilities. This research highlights the importance of culturally informed evaluation as AI systems are increasingly deployed globally. The paper, Internal Chain of Thought, Layer-Wise Subtask Scheduling in ILMS by Yang and colleagues investigates how large language models process complex reasoning tasks internally across network layers. The researchers hypothesized that these models implement what they term an internal chain of thought, decomposing complex tasks into subtasks and processing them sequentially despite their parallel architecture. To investigate this hypothesis, the researchers developed a benchmark of 15 two-step composite tasks with clear subtask boundaries, enabling precise analysis of how the model processes each component. They employed innovative techniques such as layer-from-context masking, which involves masking the activations from specific layers when processing different parts of a task, allowing them to determine which layers are critical for which subtasks. They also developed cross-task patching, a novel method that involves substituting activations from one task into another at specific layers to identify where different types of information are processed. Their findings revealed that language models do indeed implement sequential reasoning through layer-wise processing, with earlier layers handling initial subtasks and later layers handling subsequent subtasks. These discoveries challenge our current understanding of how neural networks process complex tasks and provide valuable insights into both the capabilities and limitations of current language models. The paper on the strawberry problem investigates the consistent failure of large language models at seemingly simple character-level tasks, such as counting the number of letters in words. This research reveals how subword tokenization methods, particularly byte pair encoding, fundamentally impede symbolic computation by merging or obscuring atomic reasoning units. The researchers introduce the concept of token awareness to formalize how poor token granularity disrupts logical alignment and prevents models from generalizing symbolic procedures. Through extensive experimentation, they demonstrate that atomically aligned formats unlock strong generalization in reasoning tasks, while misaligned tokenization causes failure even with chain-of-thought prompting. What makes this research particularly significant is its identification of a fundamental architectural limitation in current language models that has been largely overlooked. The findings suggest that symbolic reasoning ability in large language models is not purely a function of model size or training methodology but is deeply conditioned on token-level representations. Perhaps most surprisingly, the researchers show that even small models with appropriate tokenization can outperform larger systems in structured reasoning tasks. This challenges the prevailing assumption that scaling alone will solve reasoning limitations in language models and suggests that fundamental architectural innovations may be necessary for further progress. Looking ahead, computational linguistics research is poised to explore several promising directions. Token-aware architectures represent one frontier, with researchers redesigning tokenization methods to improve symbolic reasoning capabilities in language models. This approach could address fundamental limitations identified in current models, potentially enabling more reliable performance on tasks requiring character-level understanding. Culturally informed AI development is gaining momentum, with increasing focus on creating globally responsible models that respect diverse cultural norms and reduce harmful biases. Multi-agent systems are likely to become more sophisticated, with specialized collaborative frameworks tackling increasingly complex language tasks through division of labor and expertise. Efficient reasoning remains a priority, as researchers seek to balance computational cost with performance in real-world deployment scenarios. This includes developing models that can dynamically adjust their reasoning depth based on task complexity. Finally, ethical safeguards are becoming integral to research agendas, with systematic approaches to addressing privacy concerns, bias mitigation, and hallucination reduction. These directions collectively suggest a shift toward more responsible, efficient, and capable language technologies that can serve diverse global populations while respecting important ethical boundaries. The content presented in this podcast was synthesized using advanced AI systems, including GPT and Anthropic's Claude 3-7 Sonnet 20250219. The spoken narration was produced using Google's advanced text-to-speech technology, while visual elements for the accompanying presentation were generated with Stable Diffusion image generation models. Although this represents a highly automated production process, all content underwent rigorous review by human experts in computational linguistics to ensure accuracy and relevance. Despite this thorough review process, we acknowledge that some oversights may exist in our presentation of this complex technical material. Complete references for all research discussed are provided in the accompanying show notes. This meta-disclosure highlights both the capabilities of current AI systems in content synthesis and the continuing importance of human expertise in ensuring quality and accuracy in scientific communication. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses arXiv preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv preprint server.